Okay guys, so in this lab we're going to build some molecular models using this kit. So in the box, if you open it up, you'll see there are a bunch of wooden spheres of different colors. And so the different colors, there's a little key here, but I'll go over the ones that we need to focus on. So in this model, black represents carbon, and these are the black spheres here, and I'll focus in on those in a second. Yellow represents hydrogen. Okay, so black and yellow. And then the other two colors that you need to focus on are red and blue. And so in this kit, red is going to represent oxygen and blue is going to represent nitrogen. So I'm going to focus in on a few of these spheres so you can see them a little bit more close up. So this yellow one is hydrogen. Hydrogen is able to form one covalent bond. And if you look at this sphere, you can see that hydrogen only has one hole. The black sphere represents carbon, and carbon has 4 valence electrons, and it's able to form 4 covalent bonds. And if you look at this sphere, you can see that it has 4 holes. There's 1, 2, 3, 4. Okay, and they're spaced in such a way that when we build molecules in this kit, they're going to have a geometric orientation which closely mimics what the molecule would actually look like structurally. Okay, so that's carbon. And then oxygen is going to have 2 holes. Red represents oxygen. Oxygen is able to form 2 covalent bonds. And then finally, we have nitrogen, which we're going to use just in one case. And nitrogen has 3 holes, and it's able to form 3 covalent bonds. Okay, and the other thing you have is these little wooden connectors that are going to allow us to build molecules in this kit. So that's how we're going to connect the atoms together. So the first thing they ask you to do in the lab manual is to build hydrocarbons. So hydrocarbons contain, like their name implies, hydrogen and carbon. The 4 yellow spheres represent hydrogen atoms, 4 hydrogen atoms. And the black represents 1 carbon atom. So we're going to connect the hydrogen to the carbon in this kit using these short wooden sticks. And when I connect carbon to hydrogen, I use the short sticks. So I'm going to do that. You kind of can see me doing that. And I know it's a little blurry, but I'm going to show that to you once I'm done. And so when I add these hydrogens to the carbon, I get an interesting 3-dimensional model, which has a particular shape. It's a tetrahedral shape, but you can see there is 1 carbon and 4 hydrogens. And so if we wanted to represent this in a molecular formula, we'd say it is CH4. And I'll go over that a little bit more in the introductory video. And I'll talk about molecular weights and how we calculate them. But what I wanted you to see here is how we would construct that methane molecule. It's the simplest hydrocarbon. It contains 1 carbon and 4 hydrogens. Methane. Okay, so the next hydrocarbon in this series that you're going to be asked to construct is ethane. Ethane has 2 carbon atoms. Okay, and they're going to be connected with a longer stick because that more accurately represents the bond angle. So here I am constructing ethane. I'm going to make sure that I follow the rules and make sure that carbon is able to form 4 covalent bonds. We don't want to leave off a hydrogen. So I know it's a little bit slow and I may be a little bit out of frame, but I'm going to show you this ethane molecule when I'm done. So here it is. Okay, that wasn't too bad. So this is ethane. And so ethane has 2 carbons and 1, 2, 3, 4, 5, 6 hydrogens. So this is an ethane molecule. And you're going to see that these molecules are going to quickly get more and more complicated as we add more carbon atoms. Okay, so the next molecule that they want you to construct in the hydrocarbon series where you only have hydrogens and carbons connected by single bonds. These are called alkanes. The next one in that series is propane. So the prefix prop means 3. And so I'm going to connect the 3 carbons using, again, the longer wooden sticks, because that most accurately represents the bond angle. And then I'm going to use these short connectors to add the hydrogen atoms. So I'm going to show you this. I know it's blurry, but I just want you to see that I actually constructed this for you. Okay? So it's not mysterious. And when you're putting these molecules together, if we were to do this in the lab, oftentimes one of these little atoms, when you're trying to put it together, rolls out of the way. So I'm pretty lucky here. They're cooperating. Okay, so I have one more hydrogen to add. And here we go. So here is a propane molecule. Okay, so when you look at it, I know it's propane. I know it's a hydrocarbon because I only see black atoms, black spheres, which represents carbon, and yellow spheres, which represents hydrogen. Okay, so the black carbons, there's 3. 1, 2, 3. And then we could look at, the question in your lab manual is, how many hydrogen atoms does it take? So 1, 2, 3, 4, 5, 6, 7, 8. So this is a model of propane. So in your lab manual, it asks you to construct hydrocarbons up to decane. Decane is a hydrocarbon that contains 10 carbon atoms. And so here I've constructed butane, and you can see butane has 4 carbons. 1, 2, 3, 4. And if you count the number of hydrogens, you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So butane has a molecular formula of C4H10. Okay, and we could do that molecular weight calculation and check that together. So what I'm going to do is construct a few more of the hydrocarbons in this series, and you should quickly be able to realize that as we add a carbon, we're going to be adding 2 hydrogens. So as we go through the series, by the time we get to decane, we're going to see that it has the molecular formula of C10H22. So here I constructed pentane, and so the prefix pent means 5. Think of a pentagon, and so a 5-sided polygon. So if you count the number of carbons, you have 1, 2, 3, 4, 5. And then when you count those hydrogens, you'll see that there's 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the molecular formula for pentane is going to be C5H12. So this quickly becomes very cumbersome, and I'm going to show you how I can cheat a little bit to quickly make out of pentane, which has 5 carbons, heptane, which has 7. So I'm going to add 2 more carbons, okay? And then I'm going to quickly add some hydrogens, making sure I fill all the bonding requirements for carbon, which means I want to make sure I fill all of these spaces. So that's what I'm doing here. Okay, and I need one more on this guy. Okay, so if you look at this, this is a model of heptane. Okay, so hopefully you could see all the carbons. So whenever I go to name a molecule, I always make sure that I count. even if I just count to myself. So if I saw this molecule, I don't want to make a mistake and incorrectly name it. I will actually walk up to it and go 1, 2, 3, 4, 5, 6, 7. And that way I know that this molecule is heptane and I didn't miscount. Okay, so it has only carbons and hydrogens. It only has single bonds. I'm going to show you how we represent double bonds in this kit, but there are no double bonds here. And so this is single bonded hydrocarbon with 7 carbons, and we call this heptane.